Hello again, everyone, and welcome back. We now look forward to our keynote by Kevin Dallas. And to pronounce him or to introduce him better yet properly, I now have Joachim Kroll, and I would like to hand it over to you. Not waste any time.
Thank you very much. Challenges of digital transformation for the new intelligent edge is the title of Kevin Dallas' keynote. And I'm very pleased to have him here. He is the CEO of Wind River. And it's 6:30 local time in the Bay Area where Kevin is located. So thank you very much again. And I hope, Kevin, you had the chance to have some breakfast already, did you?
I tried.
Right, good. Well, here it is in the afternoon, and Kevin is, as I mentioned, CEO of Wind River. And Wind River was, well, not the inventor of operating systems, real-time operating system, but one of the very early vendors, and was undergoing changes all the time throughout its existence. Founded 1981, then acquired competitors, was itself acquired by Intel, and is now acting independently again, backed by a financial investor. And Wind River made the journey from a real-time operating system company to a cloud-first tool vendor. And today, the operating system is only one component within a whole picture that I'm sure Kevin will draw for us. Kevin has a very interesting career. He started 1989 with National Semiconductor here in the vicinity of Nuremberg, only 100 miles away in Fürstenfeldbruck. That's a small town near Munich with a military airport that's not in operation anymore. But later he changed to NVIDIA and then over to Microsoft, where he became familiar with the Windows Phone business, and from there over to the embedded group and the IoT business. So Kevin has experience with more consumer-oriented business as well as with industrial business. He's CEO with Wind River since 1 year. And before I hand the stage over to you, Kevin, I would like to encourage the audience to ask questions within the Slido tool. Please take an active part and make this as interactive as possible, because we had hundreds of participants in the previous keynotes, but people only dare to ask at the very end, and so the time is then running away. So please don't hesitate to ask questions during Kevin's talk. And now, please, Kevin, the stage is yours.
Great, thank you, Joachim. And welcome everybody to Embedded World 2021. That was a great introduction. Just a little bit more on Wind River Systems. We're the #1 in intelligent edge software. We power more than 2 billion devices today. And some of the most recent achievements include the 5G vRAN deployment with Verizon. And there's also the recent Mars landing with NASA's Mars exploration program. So we're particularly proud of that. So today, it's a great pleasure to talk to you about digital transformation at the new intelligent edge. Also, the AI-first world it will enable, the positive impact this transformation will have on both the economy and society, and the new software and tools that are needed to build these new intelligent systems. As many of you know, digital transformation, it's here. More than $2 trillion in software and services will be spent by 2025. $700 billion will be spent on the intelligent edge. In fact, over the past 5 years, significant investments have been made in digital transformation. But this investment has been made in the IT department. This is the information technology department around productivity and business process automation. Now, we're entering the second wave of digital transformation, the digital transformation of OT. This is the operational technology. With a new generation of intelligent systems at the edge, These systems will have the ability to sense the environment around them, collect data, infer insights, perform deep learning, and also finally act in an automated way in the environment. Examples of these intelligent systems at the edge include autonomous vehicles, robots, drones, smart factories. So 68% of publicly traded companies are deeply invested in digital transformation, particularly in the IT. But many have hired chief digital officers, that have really been hired to ensure success of those corporations in making this transformation. So much of the focus has been on IT, which has been employee productivity, business process automation within the enterprise. What's interesting is that only 28% of these enterprises have successfully digitally transformed. And the common theme within this 28% is they're emerging from the COVID pandemic, forecasting that they're going to accelerate their efforts to digitally transform. So efforts that usually take years for them to complete have now been compressed to months. So there's a huge focus in these corporations to digitally transform. But that transformation is happening not only in IT, but it's also happening in OT. So they're proactively participating in intelligent systems at the edge. They're proactively participating in what we're calling the intelligent edge economy, where machine-generated data becomes the new currency. You're seeing new products as a service from these companies. You're seeing operations being automated. Machine-generated data being used as insight for their employees to make the right decisions. And then more contextual, more personal experiences for their end customers. So the new intelligent edge economy, where machine-generated data is the new currency, is really being enabled by the rapid progression in technology. Technology from device and far-edge cloud compute capabilities, data processing and analytics capabilities, machine learning and AI, and now with 5G. So this innovation is really causing an explosion of connected devices, 41 billion connected devices by 2025. And these devices will produce more than 80 zettabytes of machine-generated data. So realize that these machines will generate more data than humans will create by 2025. So these new intelligent systems, think of these vehicles, drones, robots, medical devices, all the way through to smart cities. They'll require real-time processing, microsecond latencies, 5 nines availability, security, and safety. This means that an increasing amount of compute, data processing, machine learning, and AI will need to be done at the edge. In fact, Gartner Group are forecasting that more than 50% of this compute will be done at the edge by 2022. The real-time requirements of these mission-critical systems makes computing requirements fundamentally different at the edge than you experience in the cloud. What you see in digital transformation is rapid progress in terms of productivity and business applications. But these are applications that can require 100 millisecond latencies and perform perfectly well for the end user. As we look at the intelligent edge and the real-time requirements, microsecond latencies are required. So again, the computing requirements are very different at the edge. In addition, we have security. Security at the edge presents a constant threat. These intelligent systems at the edge are increasingly distributed with endpoints that sit at the endpoints, far edge cloud, and this complete distributed system needs to be secured and secured in new systemic ways. We'll look at new machine learning and AI-driven security services that will be the new norm in terms of protecting these new intelligent systems. So the intelligent edge is evolving. It's evolving from this world of fixed devices, devices that we would build and we would ship, we would forget about until we got a service call from our customers. We're now moving to a world of intelligent systems now that are always connected back to the enterprise. And they'll always deliver these dynamic, personal, contextual experiences for their users. So these intelligent systems are going to be fundamentally different. They'll sense the world around them. They'll interpret the data that they receive. There'll be deep learning capabilities that will be run either at the edge or in the cloud. They'll be able to act. They'll be able to self-heal through predictive maintenance. And last but by no means least, for many of these tasks, they'll be doing these tasks in an autonomous way, in an automated way. So ladies and gentlemen, what was once known as science fiction is now rapidly becoming science fact. So the customer benefits really are significant. If you look at these customers, they're now delivering new services to their customers. They're empowering their employees with machine data insights. They're automating operations, and they really are enhancing this new customer experience. As a result, when you look at the market opportunity for our customers to be able to deliver, our OEM customers, our enterprise customers, to deliver more contextual experiences for their end customers, the opportunities are really endless for us now with the technologies that we have. So what is really interesting is you look at these intelligent systems, there are a set of new attributes that are being delivered in these systems. And these attributes are really being software driven. This means that every company in every industry is going to become a software company, or more importantly, needs to become a software company. They need software tools that provide a unified development environment. We call it a DevSecOps environment that brings true cloud native capabilities to the developer. You need software capabilities like a digital feedback loop that's able to ingest data from the device, from the asset, that can be used for analysis. There's the data vault, secure data vault capabilities, the ability to actually store that data in a secure way that respects the privacy of the customer. There's data analytics and insights capabilities, flowing all the way through to machine learning and AI for automation. All of these building blocks will be absolutely critical for the next generation intelligent system. So every industry, every customer, and from an industry perspective, it can be automotive, aerospace and defense, industrial, healthcare. Every company is going through this digital transformation. And it's the second wave of digital transformation that is so exciting. And it's all going to be software driven. And it's going to be enabling this new wave of what we call AI-infused intelligent systems, where data will be treated as the new currency and will be the source of differentiation and value for our customers. So let's talk about an example of a company that has truly been able to digitally transform, both in IT and in OT. And this company is Tesla. A few years ago, Tesla discovered, on point number 2, through the social media feeds, that their autopilot feature was actually not slowing down enough as it was going into the corners. So the customers were overriding the system as they went into corners. So Tesla sensed this from the social media feeds. They also, in number 3, leveraged their digital feedback loop with their vehicles to pull back telemetry data, to be able to then confirm, point number 4, that drivers were indeed overriding the system as they were heading into corners. They developed a curve speed adapter to be able to modulate the speed going into corners, point number 5. And then they were able to deploy these updates over the air to their vehicles as part of the new services updates that they were giving to their customers. And this is on point number 6. Number 7 is that once they'd actually delivered these updates, they're able to monitor through their feedback loop, through their social media signals, how these services or this new updated autopilot was performing, and track whether further modifications were needed for their customers. What you saw there was a true intelligent system at the edge for Tesla, where they're connected to the device, they're able to sense, provide telemetry information, analyze that data, make necessary improvements to the product through software, deliver it over the air to the vehicle, and as a result, delivering a positive experience, a delightful experience for their customers. This is the transformation that all companies will need to go through. But what does this mean? It means that we have to all build software capabilities. And this is interesting when you look at different industries, from automotive to industrial to healthcare. All of these companies, many of which are already in transition, will become technology companies, embracing software, being software driven in terms of delivering on this new paradigm. But to develop these new intelligent systems, we have to rethink the development paradigm. Again, as you think about the traditional embedded systems, the development model that we had for these closed systems is really insufficient for where we're going as an industry. We have to now think about these new intelligent systems. These are intelligent systems that really have the ability to be able to stay connected to the enterprise and be able to deliver new, dynamic, contextual services for the customer. This means that we now have to think differently about the development and the design. We need to think at a system level, solving for what we believe are the 6 design dynamics. First, adopting more of a systemic view, looking at things at a system level. We can no longer have the hardware engineers, the software platform team, the security team, applications team, operations team, all operating in silos. In this new world, we need to be able to provide a unified development environment where all teams can work together on this distributed system, on this intelligent system. Next, there's lifecycle thinking. The reality is, gone are the days when we could build the product, ship it, and forget it. This intelligent system will be connected with a digital feedback loop that allows the products to dynamically adapt to the context and personalized experience of the customer. This means that we have to build the software in such a way that it maps to the 4 stages of the product's lifecycle. And these 4 stages as the development of your intelligent system, the deployment, operations, all the way through to servicing. So we have to look across all 4 stages of that lifecycle. The third dynamic is really a design process that needs to scale. And that design process has been widely adopted on the enterprise side around cloud native processes, cloud native capabilities that have been used to create these hyperscale solutions in enterprise. So there's a lot that we can learn there in the OT side of the world in adopting many of those scalable processes. Number 4, understanding specific functionality and availability of these services is critical. Paramount importance is the uptime, often measured in nines. For intelligent systems, 5 nines availability is really a must, which means we have to design failover systems, update capabilities that guarantee this level of availability. Because many of these mission-critical systems are going to be used in life and death situations. So we absolutely need to make sure that that availability, that reliability is in place. The 5th dynamic is real-time performance. This means that at the far edge, not only does the operating system in the edge device or endpoint important, but also the far edge cloud is equally important. So these intelligent edge applications, they can't tolerate hundreds of milliseconds of round trip delays to the cloud. This has to be more of a microsecond type of latency for the intelligent edge in order to support these applications that again are in life and the difference between life and death. So the velocity, the volume, the value of data really matters. The ability to process that in almost real time at the edge becomes more and more critical. So we need to design these systems in such a way that we think about the real-time requirements. And finally, security. Security is not just at the device level, but also thinking through how do we secure at the distributed system level. Many of these systems will have multiple nodes, multiple endpoints, far edge clouds, and operate in a very distributed way. How do you secure a system at that level? So there will be new machine learning and AI-enabled services that will secure these future intelligent systems. So this means that there's a fundamentally different platform of software and tools needed for these new mission-critical intelligent systems at the edge. We will need tools that meet the developers where they are. Today, 1/3 of developers are building cloud-native applications, and this number is increasing by 30% a year. So it's important that the tools that we create meet these new class of developers. The tools will need to bridge rich cloud-native capabilities like DevSecOps toolchains. Sorry, just a minute. Yeah, it's like DevSecOps toolchains, like Kubernetes containers. And these are going to be the real challenges that we'll have with these tools. And what's also interesting is when you look at these developers that are going to use these tools, I said earlier that 1/3 of the developers are building cloud-native applications. That number is increasing by an amazing 30% a year. So it's really important that these new capabilities are brought to these developers. And again, capabilities like DevSecOps toolchains, Kubernetes container runtimes that run from the cloud all the way to the edge. We want continuous integration, continuous delivery. Operation services like data analytics, machine learning, and AI. And of course, there's the predictive services that can really optimize the uptime of these intelligent systems. All these capabilities are going to be absolutely critical for us to deliver with a unified tool set and a unified set of software for our customers. So what's going to be really important with these tools and these software runtimes is they need to be able to map to the full life cycle of the intelligent system. As I mentioned earlier, this life cycle includes the development. So you've got the design and the development of your intelligent system. There's the deployment of the software of those systems and updates around those systems. There's the operations. Now think again about the digital feedback loop, staying connected with the product, monitoring the telemetry information, the ability to take real-time actions and deliver new services to the customer in a dynamic way are going to be critical. And then finally, we really want to move to a world which is a predictive maintenance world, a world where we're able to predict failures, address those failures before our customers see those failures. I talked about Tesla and how they were able to respond to the autopilot scenario. We have customers like ThyssenKrupp that have built that capability into their elevators. We have many other customers doing the same thing. So again, thinking across development, deployment, operations, and servicing is going to be critical. So I'm not going to talk too much about Wind River and our offering. I have one slide here where I just want to summarize that in January of 2021, Wind River announced the first cloud-native tools and software for mission-critical intelligent systems. And these are mission-critical systems that require real-time performance, 5 nines availability, security, and safety. We provide a rich set of software runtimes and applications that power all 4 stages of the intelligent system lifecycle: development, deployment, operations, and servicing. Again, we're the first in the industry to deliver this, and we're continuing to innovate in delivering Wind River Studio, our new offering, into not only aerospace and defense, telecommunications, but industrial, automotive, healthcare, and other growth markets like energy. So we're really excited about this new offering. And this offering, again, is cloud native and cloud-based, and really takes into account the new work paradigm that we're all experiencing as we look to exit the COVID pandemic. So finally, we're excited about the opportunity ahead. There's significant spend by the industry on digital transformation, more than $2 trillion by 2025. 700 billion will be spent at the intelligent edge. This is the area that all of you and Wind River are invested in. And we look forward to working with you all as our partners and our customers in realizing this new and exciting digital future. So with that, thank you. And I believe we're now going to move towards a Q&A session.
Thank you very much, Kevin. That was a great presentation and a very clear picture of the challenges that are facing developers today. If I look at my Slido pad here, there's a question from one person of the audience who's asking, in your opinion, what's the biggest or the major difference or the challenge between transformation between IT and OT?
Yes, the biggest challenge we believe is really providing the tools that are needed for OT. The tools that have been used to transform the enterprise side, the IT side of our business, are very different from the tools required in the OT side, particularly around the real-time requirements. When you're talking now about milliseconds versus microseconds, we're talking about the need for high availability. So enterprise grade availability of 3 or 4 nines is sufficient for business productivity. But in terms of these new real-time systems at the edge, they're in very critical situations like autonomous vehicles, drones. Here, you absolutely need 5 nines availability. And then, of course, you have security and safety, because now you're talking about the difference between life and death. So again, making sure we have a different class of tools that are able to deliver on a brand new proposition at the edge.
How does that affect the development tools? You mentioned already the real-time aspects, and that has to do with the operating system. Is the development chain almost the same, or are there also differences between the coding and the tools, etc.?
Yes, we think the development chain changes in that in the past it was sufficient to you develop your product, you test your product, you then release that product. And now what we're finding is that in the development itself, it's more of a distributed development in terms of the platform that's required. So the platform can run at your far edge device in combination with the far edge cloud. And there may be elements that actually run in your public cloud. So you have applications, you have a platform and a container-based application that runs across a very distributed environment. That's point number one. Mm-hmm. Two is that the way in which software is being deployed now. So instead of developing your monolithic software, you ship it with your product and you forget about it, there is now a need to be able to include in your development pipeline the ability to do service updates and deploy those seamlessly and continuously to your product. So that has to be incorporated in your development pipeline.
Mm-hmm. May I
go ahead?
Pick one aspect of your answer, because you had one statement in your slides that was not fully readable to the audience, maybe to a possible animation, and it was very significant. I found it brilliant, and that said, develop once, deploy forever is over. That sounds good and is understandable, but of course, as you mentioned, the devices need to adapt over life cycle to learn. But what about certification? That's a nightmare for a certification officer if the system changes its behavior over lifetime.
Yes, and we're working with industry leaders in this area. As you know, we're a leader in the area of certification, particularly in the aerospace and defense sector. Mm-hmm. So what we're looking to do is to take the learnings there, and then we're looking to take it across multiple industries. But you're absolutely right. Certification does present a challenge. Certification has traditionally taken years to complete, particularly in aerospace and defense. And really what our customers want to do is to get down to months for certification. Mm-hmm. So how are you able to get certification down to months, and how are you able to enable a model where you can continuously improve and heal your product when it's out in the field? So those are real-time problems that we're looking to solve with our customers and our partners.
Mm-hmm, mm-hmm. One question from our audience is concerning the data that is coming from all the sensors out of the real world and the data volume that's associated with that. And the question is, from a data storage point of view, what are the shares you would expect of different edge applications data being actually stored, either right side on the edge device, then transferred and stored in a near or far edge server and stored in the cloud? Or maybe you can give us some percentage figures, what you would anticipate.
Yeah, I would say that up until now, much of the data, or many of our customers, frankly, either haven't collected the data, or they've collected the data and have not been able to unlock the value of it. I mean, that's really what we've seen from many of our customers. Again, either not collecting it, or they've collected it but haven't determined how to unlock the value. Moving forward, I see a world in which we're able to systemically collect machine-generated data. We're able to store that data in what we call a data vault, a secure vault, private vault for the customer, that they can then use the latest analytics tools to unlock value. Now, where will that data reside? An increasing amount of that data will need to reside at the edge, where it can be actually processed in pseudo real time for the application. And what will happen is there'll be a certain amount of data that's needed that will be sent to the cloud, more for the learning side of the equation. So you'll get huge amounts of sensitive information stored in a data vault, analyzed at the edge increasingly. And then there's going to be differential information or learning information that will be sent to the cloud for the deep learning algorithms. And then there'll be action again taken at the device. So I could see a good 80 to 90% of the data being at the edge, with 10% being at the cloud.
One more question that arises from the audience is, how do you see the interaction between the hardware people, the software developers, and the behavior specialists that now come into place, which have to work together on a device? There will now be a third party in the play. I assume that's the behavior specialists, which has not the case been before.
Yeah, that's a great question. And frankly, we see this as an opportunity. Traditionally, many of these departments have operated in a very siloed way. You've had your hardware team, you have your software team, there's a security team. Now you also have data science teams and operations teams that really have operated separately. There's been an interface between them, but do they all work in one environment where they're really looking at this intelligent system in a holistic way? No, we don't have that today. But what we've tried to do at Wind River is deliver through Wind River Studio this unified environment that really gives all of these different engineers the ability to work together in one common environment on their intelligent system. So again, you've got your behavioral scientists, you've got your software engineers, hardware engineers, all the way through to operations, all being able to work together on the intelligent system, all being able to view a common stream of telemetry information.
Thank you. And as Wind River has in its portfolio either it's Wind River Linux and VxWorks, there's another interesting question. How do you see the open source world growing in this market? I see a trade-off between security needs and the ability to develop on a much larger scale. Would you agree that the Linux system is gaining share? Interesting question. What will happen to the real-time systems?
It's a great question. We're seeing increased need on all fronts. So first of all, from an open source perspective, we think open source is the future of innovation. The fact that you have open source and so many smart, talented individuals contributing, the rate of innovation cannot be matched when you look at open source compared to what an enterprise could do on its own. So open source is the future. So what we've decided to do as a company, really is to leverage open source wherever possible to drive innovation for our customers.
Mm-hmm.
The next thing is when you look at open source, particularly around Linux, yes, absolutely, we're seeing, again, an explosion in the application of Linux, not just in the end devices, but also at the far edge cloud that we're also delivering. So a huge need for that as well. We're also seeing growth around the real-time requirements of Linux, and then the hard real-time requirements of VxWorks that we have. So again, we're seeing just huge demand right now from our customers as they look to build these intelligent systems. And they think about the runtime requirements, not just at the far edge, but to the far edge cloud. And they're also thinking about the new container-based application model that needs to run across this distributed system.
Mm-hmm. So finally, a growth everywhere. And because Wind River has a big customer base, one question here is, Wind River serves many OT areas like telecom, A&D, medical, industrial, consumer, aerospace. In your view, which areas of embedded systems are now leading in this transition to cloud native?
All the industries are moving aggressively. I mean, if I look at industrial and Industry 4.0, just tremendous advancements going on there. I look at Siemens, ABB, Schneider Electric, GE, all these companies are making huge strides there in terms of moving towards smart factories and industrial IoT. So great advancements being made there. Automotive, same thing. If you look at what Tesla has done, they had a lead a few years ago, but all of the major car companies now have feedback loops connected to their vehicles and are now proactively using telemetry information.
Mm-hmm.
Aerospace and defense, same thing. In fact, I find that in aerospace and defense, the reliability, the availability, the security, safety are even higher requirements in aerospace and defense.
Mm-hmm.
And then, of course, telecommunications. I mean, the recent work we've been doing around 5G vRAN is also, again, really laying the foundation for this new intelligent systems world. So again, we're seeing rapid adoption across all the industries that we serve right now. And this adoption is around mission critical intelligent systems, which is what I'd really like to clarify.
Mm-hmm. You mentioned that Teslafication of the industry and all the data that's involved with that and the data coming from the devices and the cars. But Tesla had one advantage. They started basically with a blank sheet of paper. So what should do all the other automotive innovators? They have their code base. They have an installed base of diagnostics devices, an existing telemetry infrastructure. So how could they integrate, for example, their legacy code and their existing devices into that landscape and make them fit for the future?
Yeah, I think it's really identifying the right partner to work with. I mean, for many of these companies, the first thing to realize is that a lot of this value is going to be software driven. So it's very important to build a software competency.
Mm-hmm.
And software capability. And many companies are doing that where they have large software organizations now. And the next stage is once I've actually made that investment in capability, I need to work with the right partners that are going to provide the tools and software that I need to build out my platform. And what we at Wind River are doing is we're delivering a platform that enables our customers to build their own platform. So think of us as being more of an enabler. And what they'll expect from these tools is the ability to meet the developers where they are. So the investments that they've made, and we're finding this right now with many of our customers that have made decades of investments in VxWorks, in Linux. How are we able to meet them where they are and bring them to this new cloud native world? How are we able to encapsulate the investments that they've made and bring it to the intelligent systems world? And the key to that for us is offering more of a DevSecOps development pipeline that is based on largely on open source, that has moved to a framework of Kubernetes containers, where applications can run in a container environment, which means you then give the developer the ability to mobilize that application across your cloud to the edge. So all of a sudden, these rich cloud native capabilities of DevSecOps development, continuous integration deployment, operations now become available because we've been able to move our customers into this new environment.
Yes. Thank you very much, Kevin. Unfortunately, I was not able to pick up all questions here from the Slido. I would encourage you to send these questions via the chat function to Kevin. Hope he is able to answer some more over there. And while we are now continuing with the rest of the conference, I would like to say thank you very much, Kevin, for this great keynote. And you mentioned you try to have some breakfast. I hope it will not only stay a try anymore, and you may grab some coffee or tea now and something to eat. And with that, have a nice day. Thank you very much. And thank you to the audience following us.
Thank you, Joachim. Thanks for having me.